The gyroscope is a device consisting of a wheel or disc mounted so that it can spin rapidly about an axis which itself is free to alter in direction. The orientation of the axis is not affected by tilting of the mounting. They can often seem to defy the laws of physics. However, these devices actually serve as perfect examples of several laws of physics. So how does it work? Well, it's rather simple. A spinning disk resists changing forces to its orientation due to inertia. When it is positioned, in order for gravity to make it fall, it needs to make it change its orientation. But the force of inertia is greater, and therefore since gravity cannot make it tilt, the gyroscope is stable in that position. When the spin decreases enough, gravity wins over inertia and it falls. Their ability to seemingly defy gravity is a product of angular momentum, influenced by torque on a disk to produce a precession of the spinning disk or wheel. The Earth is actually a great example of precession. As you know, the Earth's rotational axis actually lies at an angle from the vertical, which, owing to its angle, traces a circle as the rotational axis itself rotates. Inertia is the resistance of any physical object to any change in its position and state of motion. This includes changes to the object's direction, speed, and state of rest. Inertia is also known as Newton's first law, which states that anything in motion will stay in motion with the same speed and same direction unless acted upon by an unbalanced force. The effect is enhanced the faster the disk or wheel is spinning, as Newton's second law predicts. Newton's second law refers to the behavior of objects when forces are unbalanced. It states that the acceleration of an object depends on two variables: the net force acting upon the object and the mass of the object. The net force is directly related, whereas the mass is inversely related. Although the gyroscope is a simple apparatus, it has many important uses and has helped develop technology throughout the years. You can find them in airplanes, helicopters, space stations, rovers, and anything that spins. It's the phenomenon that makes the gyroscope so fascinating. A typical airplane will have an entire array of them, including a plane's all-important compass. Next time you board a flight, be sure to thank Leon Foucault for inventing the gyroscope.